Chapter 11, Process Monitoring. After the implementation and deployment of the redesigned business process, there is always a risk that some expectations are not met. In order to gain an understanding of why that happened, it is essential to know what is happening during the execution of the process. This is where process monitoring comes in and can be found in the last step of the BPM lifecycle. Context of process monitoring. In essence, during the execution of a business process, data is generated. This data is then used to gain insights into how the process is performing and validate its compliance towards regulations and policies. To evaluate and gain insights about the processes, different techniques can be used. The process monitoring techniques can be divided into two distinct categories, which are offline and online process monitoring. The main differentiator between these two is when the analysis is taking place. For offline process monitoring, the main focus is to analyze the process executions using historic data. For example, using event logs for specific time periods. Event logs can contain records of incoming and outgoing messages, or when a task has started. Online process monitoring, however, is more concerned with processes that are currently running. Another way to divide it is with statistics-based, which uses statistical analysis, and the other one is model-based techniques, which uses process models. Process performance dashboards. To assess performance of a process, graphical representations can be used with process performance dashboards. Dashboards can be categorized by operational, tactical, and strategic. Operational dashboards is concerned with participants of the process along with operational managers and is more focused on the short term. The second one, tactical dashboards, is concerned with process owners and functional managers along with analysts. The time period in this dashboard is longer than that for operational. Strategic dashboards focuses on executive managers and gives a high-level outlook of the process performance with several dimensions. Process mining techniques. Process mining allows a deeper performance overview compared to tactical dashboards, as mentioned above, and also brings a new level of understanding to the execution. Techniques for process mining can be classified in four ways: automated process discovery, conformance checking, performance mining, and variant analysis. All these techniques utilizes event logs as input, and before starting working with these techniques, there are several challenges that needs to be solved when it comes to obtaining these logs, and also often require a substantial amount of effort. Four major challenges can be identified. The first one is the correlation challenge, where the difficulty refers to how to identify the case that an event belongs to. To solve this issue, entity identifiers such as order or invoice number can be used. Timestamping challenge. This challenge revolves around the issue of the timestamps of events being inaccurately logged. Sequential events can therefore have the same timestamp. Solving this requires domain knowledge, for example, like knowing when events are known to occur. The third one is the longevity challenge and has to do with the issue of mixing both complete and incomplete cases, which ultimately can lead to a faulty analysis. This issue can occur with long-running processes. To avoid it, consider removing incomplete cases. The last one is the granularity challenge. When conducting analysis on the event logs, it is usually done on a conceptual level. However, an event log's granularity can often be much finer than that, which means that each task could map to a whole other set of events. After solving these challenges, the output will result in event logs made up of traces and can be rewritten into workflow logs. Using more advanced process discovery techniques, it is possible to work out how many times a unique trace is observed in the event log. As we mentioned earlier, these process mining techniques can be divided into 4 different ways. We have the automated process discovery, conformance checking techniques, performance mining, and variant analysis. The first one is automated process discovery, which works by taking an event log and then they produce a model of the business process, which is supposed to match the observed behavior of the event log. In a way, so traces of the event log can be replayed. Within the domain of automated process discovery, there are several more techniques that are being utilized. One of them is the dependency graphs and is a technique used to visualize event logs. The way it works is by letting each node represent an event class or task, and the surrounding arcs is represented by a so-called directly follows relation. The arc is visualized between 2 of the event classes, for example A and B. If there exists an instance where at least one trace of B comes directly after A, we can say that the arc exists. These instances can be annotated with an integer to represent how many times this occurs. It is widely used due to its simplicity and the ability to perform abstraction operations. Abstraction operations means that the dependency graph can be reduced by removing a sample of nodes, for example, the most infrequent one, and therefore ending up with a simpler dependency graph. The alpha algorithm is also a part of automated process discovery. The algorithm in itself is simple, but makes one critical assumption, which is behavioral completeness. This occurs when a task can be followed directly by another task. The algorithm works by splitting the event into 2 phases. First, an extraction of order relations, which are tasks made up of pairs which follow each other in a log. Occurring between these pair of events are made. Secondly, using the extracted relations, a process model is constructed. Finally, a set of relations known as causality, parallelism, and no direct succession is constructed using these order relations, and that is what is known as the alpha relations. To handle the limitations of the alpha algorithm, more robust process discovery technique can also be used. Some of these are heuristic miner, inductive miner, and split miner, which generally works in similar ways. They construct a dependency graph and deal with noise by removing some nodes. Then heuristic rules are applied, which results in a BPMN process model. Second, we have the conformance checking techniques, which uses inputs from both the event log and the process model, and produce an output of differences between these 2 inputs. The main goal is to check if by executing a process it can follow some type of predefined rule. If, for example, the rule is not confirmed, it is known as a violation, and these violations need to be identified. These violations can be connected to control flow along with data and resources. With control flow, the analysis of conformance can be split into either constraints or normative process models. There are 3 types of constraints: mandatoriness, exclusiveness, and ordering. Mandatoriness are tasks that are required from the perspective of control. Exclusiveness reiterates the fact that multiple tasks are not allowed to co-occur in the same case. Finally, ordering states that the occurrence of 2 tasks must be subsequential in a given order. Furthermore, conformance can also be verified by doing a comparison of observed behavior and a process model. The reason behind this is to see if either some behavior in the log that the normative process model does not allow, and to see if the model shows any additional behavior that the log does not confirm. To do this, 3 techniques are required: replay, trace alignment, and behavioral alignment. For the replay step, every trace is checked by replaying them against the model. After each trace has been replayed, it is determined if that trace was allowed. Replay techniques comes with limitations which trace alignment helps solve. This technique helps find corresponding traces and shows how much divergence exists between traces. Since trace alignment does not cover task repetition, behavioral techniques can be used since it works by taking the entire event log at once and not one at a time, and therefore other differences can be observed. For the conformance of data and resources, it is important to check these for the business process. Constraints need to be examined to discover where certain forbidden values can be discovered. Also, constraints in terms of required permissions to execute certain tasks can also be discovered. Then we have the performance mining, which takes the same inputs as the previous technique. That is, a process model and an event log, but in this instance, it produces an enhanced process model, which usually contains more elements and can, for example, be used to identify bottlenecks. 4 dimensions, commonly known as the devil's quadrangle, which includes dimensions of time, cost, quality, and flexibility, is used to assess performance. In time, cycle time and waiting time can be said to be among the most important measures, mainly focused on temporal occurrence and the probabilities concerning events. For costs, we have direct and indirect costs that needs to be accounted for. To help assign indirect costs, activity-based costing can be used. For the quality aspect, it can be assessed by checking for repetitions in the logs. If a repetition occurs, it is generally a bad sign for quality. The aim then becomes to calculate probabilities of repetitions occurring using the event logs. For flexibility, we refer to the amount of variation that can be allowed in the process. Assessing the flexibility in processes, we can present issues when it comes to lack of standardization, for example, if a process proves to be too flexible. Lastly, we have the variant analysis, which uses 2 separate event logs as input and produce a list containing the differences. This is necessary because process performance tend to vary, and using the variant analysis, we can help to identify why some of these processes perform better or worse than others. The analysis can be done in 2 ways, either manually or automatically. Manually, 2 models are being compared visually with a frequency view and performance view, and from there differences can be discovered. Alternatively, log delta analysis can also be used by producing patterns with 2 event logs used as inputs. The patterns are then analyzed to discover differences. Process mining in practice. To apply all these techniques that we have mentioned, they are often used together. To help do this, 2 approaches are being used. The first one is the exploratory approach and is mainly driven by curiosity and they want to gain an understanding of how we can execute a business process. Normally, we don't have the question that we want to be answered beforehand, and this is often the approach to start with to get a better picture of the process. Second is the question-driven approach, and is usually driven by more specific questions to a business problem. This approach can be divided into 5 distinct phases. First, the problem has to be framed. Second, data needs to be collected. Third, the data has to be analyzed. And the last approach is And last, a formal proposal is formed that is concerned with how a process can be improved.